want to welcome you to my lecture today. Before I get started, uh, I really want to talk about the grading of assignment one. I've reached out to my TA. I've not heard from my TA, but I can assure you, if I didn't hear from my TA, I will take the grading responsibility today and make sure that your assignment is graded because of the fact that you need that to be able to have a confidence in preparing for our exam on Friday. So, like I said, if I did not hear from my TA, and of course, I'm actually going to grade that myself. Okay, so those of you online, can you confirm if you are seeing my lecture slide?
Yep, we
Those
can
of
see
you
that.
online, we can see that. Thank you so much. Okay, so I have two lecture materials today to accomplish. I'm going to first start with the Dumming variable. Okay, so I want to welcome you to this topic, Dumming variable. Okay, so in the outline, okay, give me 1 second. In the outline, um, I'm actually going to walk you through the understanding of Dumming variable. What do we mean by Dumming variable? And of course, how do we fit regression model with Dumming variable as a predictor variable? When I say predictor, I mean the explanatory variable or the independent variable. So what is domain? Okay, the word domain is actually, used, to, describe an outcome that is dichotomous. Dichotomous is either this or that. Particularly, at times, when I'm looking at if you take a look at our independent variable x, the one we've been doing, the independent variable s was continuous, right? Up to date. But what of in a situation where the independent variable is categorical? Categorical. What do I mean by categorical variable? The categorical variable is a variable with levels more than one. An example of a categorical variable is gender, male or female. Okay, male or female. Okay, so uh, the domain, if I want to introduce a domain, that I can say, okay, I'm going to use 0 for male, 1 for female, or 1 for male, 0 for female. It doesn't matter. The numbers we are assigning is just for labeling. Okay, the fact that I actually label female as 1 does not mean that female has numerical advantage over their male counterpart. That is not what we mean. Okay, anyone, you can decide to use 0 on anyone or 1 on anyone. So this is an example of a dummy variable. So the 0 and 1 now are actually used to represent different levels of that particular categorical variable, female. I mean the gender. Okay, so that is what we mean by dummy. So in statistical analysis, when your predictor, I mean your independent variable is categorical in the sense that it has two levels, just two levels. For information, we got some categorical variable that have more than two levels, like race. Okay, race. In race, you have the white, the African American, Latino, and the like. So they're more than that. So we have more than two levels. But here we're focusing on the one that actually have two levels. Now, let us look at this research question. What is the relationship between wage and marital status in 1985? The marital status here is categorical. Okay. The wage is continuous. The wage is dependent, right? The wage is dependent. One of the conditions for using linear regression is that the dependent variable should be continuous before you can use linear regression. Apart from having other assumptions that we've talked about in the past. The nature of the dependent has to be continuous. Okay. And in the past, we've handled situation where the nature of the independent variable is continuous. But what makes today lecture different is a situation whereby the independent variable is categorical. It's not continuous. And if you take a look at that, I'm actually calling X status, married or single. That's two levels, right? And Y wage. That's an hourly wage in dollar. Now we have data set, okay, where you actually that have collected number one in the data set the wage of $9 per hour, and that person is married. Another person is earning $5.50 per hour, is married, and another person earns $3.80 per hour and is single. Now we have all this information. We have the data set, and we basically want to characterize our relationship between the two variables. And one of the variables, the independent variable, is categorical. And therefore, we're actually going to use the idea of dumming. So which means the one that is categorical will be called a dumming variable. Okay, so when you take a look at the picture, what you see in display is what we call a box plot. Has anybody seen a box plot before? Okay, you've all seen that, right? Now, why do I have two box plots? I got two box plots because the nature of the independent variable is categorical. I'm going to have a bus plot for married, and I'm also going to have a bus plot for single. So take a look at that. The idea of this bus plot will enable you to compare the median, the mean. Take a look at that. In a bus plot, you're actually going to have what we call a 5-number summary. Okay, 5-number summary in a bus plot, 5-number summary. So when we talk about 5-number summary, as you're looking at that, when you have something like this, okay, so this is the minimum, okay, this is the first quartile, okay, this is the second quartile, this is the third quartile, and this is the maximum. If you take a look at that, that's why we call it 5-number summary. So why do I need to plot the two? This is for comparison. We are comparing the wages of married and single in a particular place. Okay, so what you're seeing in display is part of the preliminary investigation that okay, I actually want to figure out what is the relationship between the two variables. Let me first start by way of graphical analysis that I actually call descriptive statistics. Take a look at that. That is actually sending a story. When you take a look at the single, you see a particular data point that is far away in a single, right? Looking like an outlier. Okay, that's not where we're going. Now, we have data set. How do we fit linear regression here? Okay, MOD equal LM wage on status, data equal to CPS. The same way you fit linear regression. Okay, it's the same way you're going to do this. Okay, the only thing here is just like your independent variable status is categorical. It has two levels, married or single. Now, this is the result. Of course, every typical linear regression result will be displayed like that. Of course, right? I need you to pay attention to something in the output. Please pay attention now. In the output, after I intercept, what do you see? Status single, right? Why? Why do we have a status single? Okay, despite the fact that we got two levels of the categorical variable, marital status. Why is the arrow reporting status single? Arrow is reporting status single because arrow has automatically coded single as 1. Does that make sense? The one, we're not saying status married, right? We're not saying married, right? The one that you don't see, R has automatically coded that as 0. Please pay attention to that. Whenever you are looking at the effect of categorical variable on a dependent variable, and you look at the output, the arrow output, okay, okay. Now, and you can only see, because the arrow output is just going to report a level out of the 2 levels. It's only 1 level that will be reported, and in this case, it's reporting single. Okay, and the reason why it's reporting single, R has automatically coded single as 1 and coded married as 0, because this is where your data was initially. You see the way your data was under the status, it was just that there was no numbers. When you put that into R, okay, R will do the job for you. You are not going to be the one that will be do the coding yourself. Okay, so I'm just trying to tell you now. So you are saying status single, that automatically means R has coded single as 1 and coded married as 0. Now the married that is coded as 0, where is it? That married is in the intercept. Does that make sense? That married is in the intercept. You remember Y intercept in high school. What is Y intercept? The values of Y when S equal to 0. This is like the values of wage when marital status equal to 0. When marital status equal to 0, we know what that means. Married. Does that make sense now? When marital status equal to 1, we mean single. Does that make sense? Okay, now, if you take a look at that now, okay, what is the model? What is the feeder model? The feeder model is going to be wage cap equal to 9.4. Of course, the way we normally write, the model, the typical linear regression model. Okay. Now, when you see that, we actually, give me 1 second. You will want to, how can we interpret the intercept? How can we interpret the slope here? Okay. In a situation where you are working with a dominant variable, your independent variable is dummy. How can one interpret the regression coefficient? When I say regression coefficient, I mean, how can we interpret the intercept and how can we interpret the slope? Now, let me tell you, the intercept here, mathematical interpretation. Okay, the intercept is the values of Y when S equal to 0, right? Now, the wage, when the status single is 0, when status single is 0, you know what you mean? You're talking about married. And what is it going? $9.40. Okay, it means the married workers on average, got $9.40 per hour. That's what it means. Okay, now how can I interpret the slope then? The slope of negative 1.09. The negative 1.09, okay, is actually saying if I move now from married to single, that's a movement, right? Moving from 0 to 1. Don't forget, when you are interpreting your slope, what do you normally say? You're going to say for every unit increase, right? In S, right? But right now, the unit increase, okay, we're not going to talk about unit increase here because the independent variable is categorical. Okay, we're going to say moving from one level to the other one. Okay, which level are we? We're married, because married is 0. So moving from married, okay, to what? To single now. Okay, that is basically going to take $1.09 from your money. Okay, if you take a look at what you see here, on average, you know what that means? On average, it means the married workers earn more than the single workers because of the negative that you are seeing now. On average, the status, I mean the single, and 109 cents less. 109 cents is $1.09, right? Okay, so that is what it means. So if you want to look at it from another statistical angle, do you know what we're doing? what we're more or less doing is we're comparing the salary, the wages of male and female. That's exactly what we're doing. Okay. And that was why you see y bar s minus y bar m means the difference between the wages of single and the wages of married. The difference between them is the same thing as the slope. So when you want to compare two means, okay, you can compare two means using the idea of a dummy regression. So the difference exists when beta 1 is significantly different from 0, because the difference of the mean is equal to beta 1. If beta 1 equal to 0, then there's no significant difference between their wages. That's what it means. But when beta 1 equal to, when beta 1 is equal to 0, there's no significant difference. But when beta 1 is not equal to 0, what does that mean? There is a significant difference. So which means if you test hypothesis on beta 1, if beta 1 is significant, then it means there's a significant difference between the wages of, of married and single. Okay, that's what we mean. Married and single. Okay, so that was what I was trying to talk about here. If you, this is, do you know what I'm displaying here? This is where you use the t-test that we've done before, t-test of means. But what am I telling the world? When you conduct two tests of means, okay, do you know when you conduct a dummy variable regression, it's also going to do the same job. The dummy variable regression, you are testing. What are you going to test? Beta 1 equal to 0. You remember yesterday we did that, right? How you can test the significance of beta 1. I told you yesterday. So what we're trying to say, what we're trying to tell the world now is two tests, two sample, two sample t-tests is equivalent to dummy regression. That's what we mean. Okay. Now, in the two sample t-test, of course, this is what you're gonna do. You get a t-test, you get a t-value, then you get a p-value, right? In the dummy regression, okay, if you want to take a decision, you need to, for us, now if I want to take a decision, I'm going to go back here now, take a look at this. What is the p-value for the status single? It's 0.02, right? It's going to give you the same p-value when you conduct a t-test. What do you get for the p-value for t-test here? It's the same. In statistics, we actually have more than one method that is appropriate for a given situation. More than one method that will give the same results. Just like this guy right now. Is there any question on dummy variable? That is the end of the dummy variable. Any question? Okay. Now I'm going to go to the next material.